All right, so thank you everyone for joining us at our webinar here. This is Metaltoad. Today you'll hear us present. I'm Nathan Wilkerson, the VP of Engineering, and David Dolan is an engineering team lead and our subject matter expert on machine learning at Metaltoad. Today's agenda is we're going to be introducing Metaltoad. We'll go into some machine learning solutions, identify common ML problems, and then review some high-level case studies that Metaltoad has worked for. And then at the end, we'll touch on some funding options that you have while working with Amazon and machine learning. So before we get started too far into it, a little bit of a history of Metaltoad. We've been around since about 2003. We're an advanced tier partner with numerous competencies and service deliveries. And we just achieved, we need to update our badge here, the Gen AI competency with Amazon. So new one there. If you enjoy this one, we have a recap of reInvent with some of the interesting announcements and use cases coming up on January 7th. And now I'll hand it over to David, who's going to go over the ML business solutions.
Sweet. Yeah, okay, let's talk AI and ML. Um, so I guess I'll start here. According to a Crunchbase article, and this article might be a little dated, I stole this from Joaquin, one in every $4 being invested right now is in some sort of AI or ML play. And what's maybe not clear to people in companies new to the space is the amount of opportunity that exists within ML and AI that's vast beyond the innovation itself. Maybe another way of saying this is that the solutions on their own are actually kind of vapid and useless until their potential is unlocked with real data. So let's take a look at some common use cases that don't really merit innovation in terms of the underlying technology, and instead could be innovations as a result of the data that's applied on it. So things like image classification, which is essentially the process of detecting types of any given thing within images. This could be as simple as checking if an image contains a hot dog or not, or as complex as determining the amount of damage a vehicle has sustained. Sentiment analysis is used to describe implied sentiment, tone, or subcontextual meaning from human written text sources. So for example, if I had lots of human written reviews and would like to categorize them based off of whether the review is good or not, or maybe a more complex solution would be to check for many sentiments on any given review to better determine why a review was good or bad or not. Anomaly detection. It's exactly what it sounds like. It's detecting unusual patterns in data, such as identifying fraudulent transactions, machine faults, sensor data, missing data. Anywhere we're interested in finding statistical outliers in a data set, anomaly detection is probably what we're looking at. Recommendation systems. These are systems that provide personalized recommendations, such as product recommendations in an e-commerce platform, or say like personalized plans like travel itineraries or diets catered to an individual. So what can we use to actually tackle these? What's actually available today to start using with my data? So if we're looking at image classifications, we have tools like Recognition, which with no additional training and a very little setup can start classifying images for you. In our previous webinar, we actually got into Recognition a bit more, so feel free to go check that one out. But basically, if the items identified are fairly common, chances are we get them out of the box with Recognition. Things like animals, everyday items, foods and beverages, vehicles, basically most business and day-to-day categories have coverage, and even beyond. For anything else that's not out of the box, the Recognition does provide essentially a pre-configured ground truth environment, a training environment to train your own classifications. And then going even beyond that, we have a number of models available to us in SageMaker or similar like Hugging Face type repos that have things like ResNet, which is a model that can be further trained on your data set. It's an open source solution. And with a lot of the open source solutions that are available within SageMaker and beyond, we're not locked into any specific cloud too, so there's some benefits there. For sentiment analysis, tools actually vary greatly, but AWS's core resource for this is Comprehend. Similar to Recognition, Comprehend is a solution that's ready to go. But it can also be extended by, you can plug in your own custom models and you can do further training too. Basically, their IP allows you to, or API allows you to submit input text and return a number of insight frames. In addition to semantic outputs, Comprehend will also return contextual extracts like person, date, location, amount, etc. And then going beyond traditional ML solutions, at Metaltoad, we've actually found a lot of great success turning to Bedrock and employing large language models to do sentiment analysis. Generally, LLMs are extremely good at determining the tone of text and taking itemized instruction around what to detect and respond with. So super powerful tool there, actually. Anomaly detection. SageMaker comes equipped with lots of algos for performing anomaly detection. RCF, or random cut forest, is specifically designed for unsupervised anomaly detection, making it a pretty good solution to get started with. And it also handles time series and non-time series data. So it's a pretty well-rounded solution for the problem. It's probably one of the reasons it's the first algorithm that AWS would suggest. RCF isn't a completely managed resource within AWS like comprehender recognition. It's also not a training-free solution. As I mentioned, it's unsupervised, and the API is incredibly friendly to use. So what that chalks up as is there's no labeling your data and no crazy steep learning curve before you can start actualizing results and seeing anomaly scores from your inference endpoint. And I guess kind of lastly in this smattering is our recommendation systems. In AWS, there's a few different solutions, but the most comprehensive solution that AWS offers is Personalize. Personalize can address things like user personalizations, like product recommendations, related items lists, item rankings, next best actions. It can also, as part of it, return you user segmentation. So basically, it can do clustering on your demographics. Once you determine the outputs, AWS Personalize manages the storage of training data, feature extraction, training, deployment, and filtering the recommendations either through a batch inference endpoint or real-time streaming API. So super comprehensive solution. It takes a lot under the hood. Any one of those things, you could kind of break out and do, on its own. But I think Personalize kind of aims to be an entire ecosystem. Now I'm just mentioning these problems and solutions here as I would think they're quite common and would probably harbor a ton of value harnessed within anybody's given industry. But there's, of course, a deep ocean of problems and solutions within this space. So if nothing else, what I was just trying to convey more or less is that you're not late. There's a ton of competition within the AI and ML space. And I would argue if you're positioned outside the space, the potential to benefit on all of this innovation is not to be underestimated. So, okay, I have problems, you have problems. What do these problems lend themselves to ML and AI, though? Where do you start? How do you know what to build? If we take a look at we should take a look at the machine learning lifecycle, and we'll hone in on business and machine learning framing. But it's worth knowing about the full life cycle to understand how the whole process works. So more or less, you're going to want to start with a business goal. You identify and clarify business problems to solve within ML. You define success criteria and key performance indicators, KPIs, and then you ensure alignment with business objectives and resources. Next is the ML problem framing. This is where you would translate your business problem into a specific ML problem. Examples being like, are we looking at classification, or is this a regression problem, right? Etc. Then you identify the target variable and you outline your input features. So basically looking at the data, what do we actually have to work with? What values are going to be meaningful for solving this problem? You establish your evaluation metrics and you make sure that that still aligns with your original business goal. Data processing, this is where we collect and prepare data, including data cleansing, transformation, feature engineering. This would be where we would look to split our data into training segments, validation, test sets, and then also kind of any of the ETL stuff would happen here. Address any data quality issues and ensure that the data is ready for model training. Then we get into model development. This is where we're actually selecting to train suitable ML models or algorithms. Optimizing hyperparameters to improve performance, validating, the models are using evaluation metrics that ensure generalization. This is all kind of part of model development. And then deployment. This is where we would take the model. Now we're no longer working in a notebook or like an isolated environment. We want to integrate this model into a production system. This would be implementing APIs, batch pipelines, deployment options. Do we need something at the edge? Setting up, infrastructure for the model in general, setting up performance, scalability, access, all the kind of good things around production things. And then the tail of this Ouroboros is monitoring. So monitoring is where we would track model performance, detect drift in predictions, model metrics like accuracy, latency, distribution, stuff like that, distribution over time, I guess, specifically. This is where we would implement retraining strategies and come up with, the plan around model maintenance and effectiveness. And the circle continues. But so if we focus on business goal, these are really kind of the questions that you should be asking, the things that you should be thinking about. A lot of these are probably familiar beyond like ML project planning. But you need to identify a clear problem to solve. You need to identify how you're going to measure success. You've got to align with your stakeholders. You've got to form a formal business question that is going to be your guiding light. And you need to review business processes that might come about from this new solution. And so good questions to have as you're going from the business goal framing into ML framing is, what problem am I trying to solve? Can I frame this question in a clear way for everybody to understand? Some more kind of stakeholder things, but they're important is, what's the ROI on this project, and is there opportunity cost for doing this or not? So all good things to look at before you get your head under the water. So with these questions in mind, we can then tackle framing better. And as a result, if we have the right questions and narratives in our mind as we go into the framing step, we can then kind of determine if the questions being asked are even frameable within an ML solution, meaning machine learning can solve lots of problems, even problems that are better solved by more traditional solutions. Generally, if a task is simple enough to be handled programmatically, like getting a row out of a CSV file, we probably want to stay away from ML and AI. To get metaphorical, basically, we don't need to be arc welding something that can just be stapled, or in the container world, we don't need to ship on Kube when it could have just been done on bare metal. So okay, let's, with time permitting, which I think we do, let's take a look at a few case studies. So beyond just, these are hypotheticals of what you could do, this is some of the stuff that we have done. So I1 Digital. I1 Digital was a fun engagement I actually was on. We worked to modify an AWS solution called Media to Cloud for I1. Media Cloud is basically an IAC package that the AWS solutions team offers as a way to generate metadata on a media library. The problem that I1 came to us with is that they have an incredible amount of video assets within their library, but no real metadata attached to their assets to search against. Basically, if their title of their video wasn't descriptive enough, they would have a really hard time gathering all their assets in a timely manner pertaining to whatever their subject was. And as a media org that capitalizes on timeliness and relevance, it becomes extremely important to have as much metadata attached to their video as possible. So recognition probably played one of the bigger roles in that pipeline. There's a lot that's kind of stuffed into the media to cloud pipeline. But I think bang for their buck, recognition provided facial recognition on celebrities, which a lot of their media contained, with absolutely zero training required of the client. And recognition does obviously come with its own way to classify your own faces. But out of the box, they were able to get a lot of the faces that they wanted to identify immediately. Genius Vets makes for another interesting case study. Their problem statement we found could actually be tackled in a few different ways. Basically, they have an ever-growing collection of veterinarian calls between clients and help desk associates. Their system has a way to flag calls for review, but due to the sheer volume of calls, the feature kind of never got used, and the resulting insights and action never really got actualized after the fact. So after trying some more traditional approaches with Comprehend and then ultimately trying to train up a blazing text model. We realized that the accuracy coming from comprehend lacked in the context of like a veterinarian setting. And then training up a model on blazing text. Blazing text is a supervised model, so we were up against requiring tons of labeled data, which again we realized we weren't going to get in a timely manner. So ultimately, we turned to generative AI and reframed our problem. We found our success here in asking an LLM to identify events and sentiments on any given call rather than addressing the larger problem of, is this call good or bad? So the LLM would just then return us a structured JSON format, which actually I have up on the screen. You can see things like, was anxiety detected? Was an appointment made? Were we talking to an emergency clinic or not? Was diagnosis discussed? All of these things ultimately were the signals as to whether a call was good or bad or not is if one thing existed with another, if it existed at all. It allowed us to define a decision tree with the client rather than having to guide a model to the same conclusions, which without good data, it gets very hard to do. Securitoad is a SaaS offering that leverages a model called IP Insights. IP Insights is an unsupervised algo that leverages entity embeddings to learn IP addresses associated with particular entities, so like user IDs or anything else that would show up in logs. It does this by generating embeddings, which are just vector representations of the relationships between the decided entities and the IP addresses. So by examining IP addresses over time, it can identify normal behavior. This is anomaly detection, is what I probably didn't say at the top here. So Securitoad is trained. It uses this model. It's trained on CloudWatch logs. It's maintained for drift, and we provide a dashboard for configuring it with a WAF, and ultimately to like visualizing the data. Sweet. All right, let's talk about funding opportunities. Nathan, would you be able to grab this one?
Yeah, so let's go talk about funding opportunities. So Amazon has, for generative AI in particular, a POC funding option where you come to a partner like Metaltoad, we can work through you with a plan, calculate your spend on Amazon, and they'll give you 10% of that annual revenue up to 25K in essentially money to develop your product. They've also recently launched a newer one to get it to production. So there's additional funding if you take it all the way to production from the POC phase. And there's a couple of other ones. So talk to our account rep, whose email will be on the last slide, Stacy. She knows all the different metrics you can do to pull in funding from Amazon. The most important thing is the funding mechanisms change from time to time, and usually they change in January. So if there's anything you want to try to get in before then, I would recommend talking to her sooner rather than later. Of course, once the new ones are out, we'll make sure to put those in our next webinar. Any questions? You can put it in the Q&A section.
Sweet. Actually, while we're waiting for questions, I'll put up the last slide just so we got the email.
Yeah. I think we don't have any today.
No problem.
Looks like a quiet
Awesome.
audience. Well, thank you everyone for joining us. Have a great rest of your Tuesday.